இல்ல
காலையில இதே தானே எடுத்த ஸ்லைடு இது மாத்தி போட்டியா?
Okay, good afternoon.
Sir, you are muted.
Vijay, we can't hear you, Dr. Vijay.
Can you hear me now, ma'am?
Yes.
Yes, yes.
Thank you. So, welcome all the participants to this post-lunch session. So, in this session, I will be just covering on the inferential statistic part. And there is a small change in our session schedule. After this session, we will be having the correlation and regression session, followed by hands-on of both the sessions will be carried out. Okay. So what is this concept of inferential statistics? Okay, so since morning we were talking about the samples and the population, the inference, everything. Okay, so something dealt with that is this inferential statistics. Okay, so inferential statistics, what will be covered in this session is that I will be going through what are the various measures of we commonly in our which we commonly use in our day-to-day clinical research. Okay, so I kindly request all the participants to just mute your mic. And kindly don't touch the screen or do any kind of annotations. Okay. So what will be covered is first I will be going through what are the various measures of association which we can use based upon our study design. Okay. So in day-to-day practice, we tend to use various types of study design based upon our research question. Okay, so either it could be a descriptive study design or analytical study design or a experimental study design. Depending upon each study design, what will be the ideal measure of association I will be dealing with. Next, how to interpret these measures of association. So measure of association here I intend is, for example, the prevalence ratio, odds ratio, relative risk. Okay, so and also this number needed to treat, absolute risk reduction. These are the various measures of association. Depending upon the study design, we will use one measure. Okay, so how to give the interpretation of this, that will also be covered. Okay, so if suppose odds ratio is 2, what does we infer? If prevalence ratio is 1, what is our inference? Likewise, we will be seeing the interpretation of these measures of association also. And then I will be moving on to the approaches for hypothesis testing. I will be just briefly explaining, because in the first session as well as in the last session, we saw about how to test the hypothesis. Okay, so you need not go or dive in depth into any of these concepts. Okay, so just framing the null hypothesis, framing the alternate hypothesis, testing them with suitable statistical tests, getting the p-value, and give our interpretation based upon the p-value as well as the confidence interval. Okay, so finally, I will be highlighting on what will be the ideal test to choose. Okay, what is the statistical test of association, the test of significance, what we tell, what to use in each of the study design or each of the scenarios, that will also be dealt in this session. Okay, so with this brief introduction, I would like to move further. Okay, so if for the participants has any doubts, you can just put your queries in the chat box. We will see to address it at time to time. Okay, so this slide, I think so many of you would be already aware of this. The epidemiological study designs, we broadly classify them into two. One will be the observational studies, another one will be the experimental studies. Okay, so what is this experimental study? What is this observational study? Observational studies are the studies in which we just observe what is going on. Okay, so we don't try to make any active attempt to change the disease process. Okay, as an investigator, we don't assign the exposures in case of observational studies. We just sit back or sit aside and just observe what is going on, and we tend to record our findings. Okay, whereas in case of experimental studies, it will be exact opposite of that, where it will be conducted under the direct control of the investigator, and the investigator will be assigning the exposure or will be making an active attempt to change the disease process by introducing something called as an intervention. Okay, so this is what an experimental study design is. This observational study design is in turn divided into two. One is the descriptive studies and another one is the analytical studies. Okay, so what is descriptive study? What is analytical study? In descriptive studies, just like the descriptive statistics, we just describe it. Okay, so either it could be in the form of percentages, or it could be in the form of frequencies. Likewise, we just describe them. We don't try to give any kind of association measure, or we don't test the association, or hypothesis testing is not done in case of descriptive studies, as there won't be any comparison group. So please remember, in case of descriptive studies, there won't be any comparison group. Just based upon our study group, we will be giving the inference. Okay, there won't be any comparison group. Either it could be an internal comparison or an external comparison. Okay, so examples for descriptive studies, we have this case reports, case series, and I will come to this cross-sectional study, because cross-sectional study can be both descriptive as well as analytical. So basically, in descriptive studies, either we give it in the form of frequencies, percentages, or we tend to calculate something called as the prevalence. Okay, if we just stop with calculating the prevalence alone, it is a descriptive study. But in case of analytical studies, what we actually do is we test the hypothesis. We tend to look for the association between two variables. Here, the dependent variable and the independent variable. The dependent variable is the outcome of interest. Okay, so the independent variable will be the exposure, or also known as the risk factors. Okay, so this is what we do in case of an analytical study, and in analytical study there will be always an comparison group. Okay, so either it could be external comparison as we do in case of case control and cohort. Okay, we have cases as one group, we compare them with controls, right? Whereas in case if it is what is this internal comparison? You are doing a cross-sectional studies. Okay, so where you have recruited participants. Okay, so you have seen the prevalence and you have seen measures. Okay, say for example, the prevalence of diabetes. Okay, so it's this much you're assuming. And you want to categorize them based upon the age category. Okay, so less than 40, what is the prevalence? More than 40, what is the prevalence? So you can formulate a 2x2 table based upon this. Okay, so this is what you do as an internal comparison. Within your data set itself, you are splitting them into two groups and comparing both them by formulating a 2x2 table, also known as a contingency table. Okay, so you will be having two columns and two rows. Then we will go for any of the statistical tests, and based upon the p-values, we will give the inferences as like. Okay, so this is what you do in case of an analytical studies. Whereas this experimental studies, depending upon whether we do some kind of a randomization, random allocation is done regarding the allocation of participants. Based upon that, we go with randomized control trials and non-randomized control trials. Okay, so just at the basic level, you just know that in case of observational studies or in the descriptive studies, we tend to just describe or study participants, and we just give the distribution of them with respect to age, sex, how they are distributed. We can even calculate the prevalence. That's it. Whereas in case of analytical studies, we tend to identify the determinants. Okay, what were the determinants for this disease to occur in that person? Whether age was associated, whether the socioeconomic status was associated, or any other variable was associated. Okay, so that we tend to find out using this analytical study design. And the information which we have obtained from both these study designs, we tend to implement it or apply it by either modifying the risk factor by introducing some kind of intervention in one group and not giving the intervention, or an alternate intervention in another group and giving us the result. That is what we do in case of an experimental study. Okay, so I hope I have made this very clear. So observational studies, we have descriptive.
Hello.
Yes. Yes, ma'am.
Sir, if we need to study gene expression in three groups, like malignant, and second one is benign, and third one is normal. So what is that type of study called?
Yes, ma'am. Gene expression in
Three groups, like
Right.
malignant group, benign group, and third one is normal group.
Okay. So it will be just a comparative observational study only, ma'am. Okay, so you just have three groups. What is the gene expression in each of the three groups only you will be seeing. If you just test the association, it will become an analytical study. If you just stop with giving the frequencies alone, or giving the prevalence, or how the gene expression is there in all the three groups, if you just stop with this descriptive part, it will be a descriptive study. Okay. So if we are just giving some kind of intervention, or if you just tend to remove any of the risk factor or some kind of a gene alterations you want to do, then it will become an interventional study. If it is not done, it is just an observational comparative study. If you test the association, it will be analytical.
Okay, thank you.
Anyway, we can formulate, ma'am, but it depends upon our research question. What is the underlying research question we tend to find out. Okay, so whether we just want to test, stop with mentioning the prevalence alone, it will become a descriptive. Okay, so if we want to test the association, okay, the relationship between the risk factor and the outcome, if you want to test, it becomes a analytical study design. Or if you just introduce some kind of intervention and you just want to test how the intervention behaves in both the groups. Okay, so what is the effect of that intervention in group A plus group B? If you want to test like this, it becomes a experimental study. Okay.
Hello, sir.
Yes, yes.
Sir, what is the basic difference between NRCT and quasi experiments?
So NRCT and quasi-experimental studies. So, okay. So in case of non-randomized control trials, we just don't tend to do any kind of a randomization. Okay, so but in case of quasi-experimental studies, at least some kind of randomization we try to introduce, and also either it will be at least a single-blinded trial we will be doing in case of quasi-experimental studies. Not all the things of the strict protocols that we will be following in randomized control trials will not be done in case of quasi-experimental, but to a certain extent we will be doing at least a basic single blinding and all we will be doing it in case of quasi-experimental studies. To qualify as a randomized control trials, we should have three things. One is we should do the randomization. There should be blinding. Okay, so it could be either single blinded, double blinded, or triple blinded, or you should you should have a concealment of allocation. Okay, so which participant we are allocating to which group. Okay, so that concealment also should be done. Concealment of allocation should also be done. If these three are done, it becomes a randomized control trial. Okay, so if none of these three is done, it is a non-randomized. Quasi-experimental is between these two.
Thank you, sir.
Yeah, thank you. Okay. So I hope then we can just move further. Okay. So next, moving on to the measure of association. What is this measure of association means? Okay. So if we want to test whether the exposure has an influence on the outcome, we tend to check something called as the association. Okay. So we use depending upon the type of the data. Okay, so if it is a qualitative data, we use one measure to find the association. Okay, so if it is a quantitative data, we use another kind of a test. Okay, and if it is two groups, one test, more than two groups, one test. Normal distribution, we go with parametric test. Non-normal distribution, we go with non-parametric test. So ultimately, what we just test is we test the association between the two variables. Here, the two variables are the dependent variable, that is the outcome variable. Outcome is always the dependent variable because it depends on the exposure, which could be the risk factor, and it is also known as independent variable. So two variables, one is outcome variable, also known as dependent variable. Next is this exposure, also known as independent variable. We are going to test these two, whether there is association between these two by using p-value. But p-value just gives us whether these two are associated or not only. But how much strong is this association? Okay, so that cannot be given by this p-value. That can be given only by this measures of association. Okay, so that is why we have to use an ideal measure of association depending upon each of the study design. Here, as we are dealing with measures of association, there is no point that in descriptive studies, we will be seeing any kind of measure of association, as we are not at all going to test the association between the exposure and risk in case of descriptive studies. There won't be kind of two variables in case of descriptive studies. So we don't go for any measures of association in case of descriptive studies. It is applicable only for analytical as well as experimental studies, right? So moving on to what is the ideal measure of association depending upon the study design. Okay, so commonly most of you would have heard about one measure of association, that is this odds ratio. Okay, because quite commonly we tend to use this odds ratio. Even it is in practice that we always misuse this odds ratio. Okay, so we use it in all types of study designs, but it is not an ideal thing to do. And one take-home message I want to give to all the participants is that never use odds ratio as a measure of association in case of cross-sectional studies, because cross-sectional study, the measure of association should be only prevalence ratio. Okay, so odds ratio is the measure of association in case of case control study only. Okay, what is this formula for odds ratio? I don't want to go in depth into the formula for each of these measures, but odds ratio usually we will be formulating a 2/2 table, right? Okay, so at the row side we will be having the exposure, and at the column side we will be having the disease. Okay, so disease present, absent in columns, and exposure present, absent in rows. Okay, so we will be formulating a 2/2 table, and odds ratio will be given by the formula AD by BC. Okay, so till now we know these things. Okay, but what is this measure of association concept? Okay, so what is the interpretation we have to give based upon that? If odds ratio is greater than 1, it means there is association or a positive association. If the odds ratio is equal to 1, there is no association. If it is less than 1, we tend to tell as negative association is present. Okay, if odds ratio is 2, how to give the inference or interpretation, how to give it? Okay, so what we tend to do is that we tend to give the interpretation in this manner. Say, for example, if odds ratio is 2, cases, okay, have 2 times higher odds of being exposed when compared to controls. That is what the inference we give. Okay, as odds ratio is the measure of association in case of case control study. Case control study is a study in which we start the study with choosing
Can you
the
repeat
cases.
the inference again? Can you repeat
Yeah,
the
ma'am.
inference
Yeah. I will come to that, ma'am. I will come to that. Okay. So what is this case control study? In case control study, we start the study with choosing cases who have the disease, controls who doesn't have the disease. Okay. So we will be going back in a retrospective manner, reviewing all their records and everything, and we will be looking and finding out whether exposure is present or absent. So exposure present, absent in cases. Same way, exposure present, absent in controls. Okay, so based upon that, the inference which we give based upon odds ratio is that case, if odds ratio is 2, what will be the inferences? Cases have 2 times higher odds of being exposed when compared to controls. That is what the inference we give. Cases have 2 times higher odds of being exposed when compared to controls. Why this term, or why we are using it as odds? Why not? Because in a majority of the studies, we want to say how much risk this exposure has when compared to other exposure for developing a disease. That is what we tend to find out, right? Okay, but why we want to say it is in odds? That is because we are not following the population. Okay, and we are not going to calculate the incidence in case of cross-sectional or in case control study. This is done only in case of cohort study or experimental studies. Okay, so in cohort and experimental studies, only we start with the exposure, right? And we will be following them for certain time period to look for whether they develop the disease. This development of disease after this follow-up, that is known as the incidence. We calculate that measure as incidence, number of new cases that has been occurred, okay, over this time period. Only when we calculate the incidence and when we follow the participants for a certain time period, and whenever there is one follow-up, then only we can give the measure in the form of risk. Okay, then only we can use this relative risk. Let it be relative risk or incidence rate ratio, or in case of experimental study, we have this relative risk reduction, everything. Then only we can give that term as risk or use that term as risk. Otherwise, we can't use the term risk. We only can use a proxy measure. Okay, so another kind of measure of that risk, that is odds ratio in case of case control studies, whereas prevalence ratio in case of cross-sectional studies. Okay, so next coming on to cross-sectional study. What is this prevalence ratio? Okay, so it is given by how much is the prevalence of the disease among exposed and how much is the prevalence of the disease among unexposed. Okay, so if prevalence ratio is 2, what will be our inference? Okay, so our inference will be exposed have 2 times higher chance of getting the disease when compared to unexposed. Okay, so exposed people, okay, as we start the study, exposed people have these many times higher chance of developing the disease when compared to non-exposed. We are not going to follow them. Both the exposure as well as the outcome we are studying at same point in time. That is why it is known as a cross-sectional study. Either if you just study it by going backwards, it becomes a retrospective study, then it could be a case control. If we are following the in a prospective manner, it will become a cohort study. So both the exposure and outcome is studied at a single point. So that is why it is known as a cross-sectional study. It is also known as a prevalence study. In this prevalence studies, if PR, that is the prevalence ratio, is equal to 2, it signifies that the exposed people have 2 times higher chance of being two times higher chance of having the disease when compared to those who are not exposed. Okay, so that is what the inference we give based upon prevalence ratio. Same manner we give it for relative risk also, but here we can definitely say the exposed have these many times higher risk because we have followed them up and we have calculated the incidence also. So we can be sure shot, we need not use any proxy measure of that risk. So we can directly go with relative risk, or also known as risk ratio. So it is given by the formula incidence among exposed, incidence among unexposed. Another one point also to be considered is that this incidence is needed to calculate the risk. Okay. Whereas in case of cross-sectional as well as in case control study, we can't calculate this incidence. That is why we can't use the direct measure of risk. Okay, so it is kind of a other way around. Okay, so relative risk, if relative risk is, say for example, 2, what inference we can give is the exposed, okay, have 2 times higher chance of being 2 times higher chance of developing the disease when compared to unexposed. Okay, so we can give in definite terms. We can use the term risk also here if it is a cohort study or if we are giving it for the relative risk. Okay, so relative risk, if it is 2, it means the exposed have 2 times higher risk when compared to non-exposed for developing the disease. Okay, so this is what the inferences we give it. Whereas if it is a kind of an experimental study, okay, so we can go with the measures like absolute risk reduction, relative risk reduction, and number needed to treat. Okay, so depending upon what to produce and whether we are going with a drug trial or whatever it might be, we can give the measure of association depending upon that. Okay, so the number needed to treat is how many persons we have to treat to prevent one adverse event. That is the number needed to treat. Okay, so these are the various measures of association which we commonly use. Okay, so mostly we go with only 3 things. Okay, prevalence ratio if it is a cross-sectional study, odds ratio if it is a case control study, and relative risk and incidence rate ratio if it is a cohort study. Commonly we will be dealing with these 3 study designs only. Okay, so not in day-to-day practice we will be doing an experimental study or an interventional study, because as an individual doing these kind of interventional studies and also a randomized trial without doing any kind of blinding and all, it's very, very difficult to do at an individual level unless you have a very good infrastructure, a very good backup, manpower, money, resources. If you have everything only, you can go with an experimental study. So basically, or in day-to-day practice, we will be doing only cross-sectional, case control, and cohort study as per our research question. So if you know these 3 measures, it is well and good. Prevalence ratio, odds ratio, and relative risk or incidence rate ratio. Okay, so these things alone, if you know, it is well and good, right? So any doubts? Shall we move further? Okay. So next, moving on to the concept of inferential statistics. What is this inferential statistics? In the morning session itself, I think I had given a brief intro about it. What is inferential statistics? What we in any kind of research we tend to do is that we choose a population. From this population, we select the representative samples. We study those samples, and from the sample results, what we do is we measure the association. Okay, so either it could be the odds ratio or relative risk. Based upon that, we assume that similar kind of result only or similar kind of parameter only will be there in the population, and we just extrapolate our result to the population or generalize our sample results which we have obtained from the total population to the total population. That is what we do in case of inferential statistics. So whenever you hear inferential statistics, the term inferential statistics, only two things has to come to your mind. One is p-value, second one is 95% confidence rate. These two are only the measures of inferential statistics. Okay, as such, the measures of association which we saw earlier, odds ratio, relative risk, prevalence ratio, they are not inferential statistics. They are just measures of association. Okay, so p-value and confidence interval, that is the 95% confidence interval of the measures of association. Say, for example, odds ratio. Okay, so if odds ratio is 2, say, for example, the confidence interval is 1.7 to 3.5. This confidence interval is an inferential statistics, but as such, this odds ratio, the measure as such, is not an inferential statistic. Okay, so that point you must be very clear. Okay, so only two things we are worried about. One is calculating the p-value. Second one is estimating the 95% confidence interval. Okay, so how to do this? Okay, so this is what we do. From the population, we tend to choose representative samples. Okay, so in the samples, we frame the hypothesis. Okay, so the null hypothesis, we will be framing it as both the sample as well as the population is not different. Okay, so they are not different. That is what the null hypothesis will be. Alternate hypothesis will be having, they are as different. Okay, so we will be estimating the measures of association depending upon the study design. Okay, so if it is a cross-sectional study, we will be calculating the prevalence ratio. If it is a case control, we will go with odds ratio, and if it is a cohort study, we go with relative risk. Okay, so based upon our measures, we give the extrapolation or we give the conclusion based upon our sample and generalize it to the total population. Okay, so we do this based upon two parameters. One is by calculating the p-value and by estimating the 95% confidence interval. Right? So how
Can
to
you tell the
calculate?
difference of
Yes.
sampling frame, sampling unit?
Yes. Yes.
No, sir. Can you tell the difference between sampling frame, sampling unit?
Yeah. That and all will not be covered here, but I will just give you a brief intro. Okay, so what is this sampling frame? This total population. Okay, so from which we are selecting the study samples. Okay, if you enumerate the list of these total population, that is known as the sampling frame. Okay, so from this sampling frame only, we tend to select the units. Okay, so individual participants into our study, these are known as the sampling units. Okay, that is what a sampling frame and a sampling unit as such mean. Okay. Okay, moving forward. So we need only, as I told, we need only two things. One is this p-value. Second one is this 95% confidence interval. Okay, so how to calculate this p-value? P-value we can calculate by doing any of the statistical tests. Okay, so say for example the chi-square test, student t-test, or ANOVA, whatever it might be, depending upon how our type of variable is, whether it is a numerical, whether it is in continuous, whether it is categorical, following normal distribution or not. Based upon that, we can calculate the p-value by testing the hypothesis. Here, as ma'am has already pointed out in the first session itself, so the exposure, again and again, I keep on just reiterating here that exposure is the independent variable and the outcome is the dependent variable. We want to test whether this exposure is associated with this outcome. Okay, so that we can test using statistical tests, and our hypothesis will be in such manner. First, the null hypothesis will be there is no association between the exposure and outcome. That will be our null hypothesis. Exact opposite of the null hypothesis, we will be having the alternate hypothesis where exposure is associated with the outcome. And we will look into the p-value. And if the p-value is less than 0.05, it means that our null hypothesis has to be rejected. And we can say that there is association between the exposure and the outcome, or it in turn means, as p-value is the probability value. Okay, so it means that for the null hypothesis to be true, there is only 5% chance. Okay, so for null hypothesis to be true, that is no association between the exposure and outcome. Okay, so there is only 5% chance for this occurrence to occur. Okay, so that is what we infer by p-value, and always look for the p-value. If it is less than 0.05, it means our variables are significant, statistically significant, and we can always reject the null hypothesis and accept the alternate hypothesis. Not exactly every time it has to be less than 0.05. If it is less than 0.05, we are having this 5%, as ma'am has told you, 5% alpha. The alpha error, if we just fix it as 5%, it should be 0.05. If we fix it as 1%, okay, so it should be 0.01. Then we can be sure that 99%, we can be sure that it should be occurring only by some kind of a sample variation, and it is not by chance. There is only 1% chance to occur, this difference to occur. Okay, so p-value less than 0.05 is statistical significant estimate that we give it. Okay, if it is less than 0.05 p-value, it means highly significant. Okay, that is what we tend to infer by this p-value. So how to test this hypothesis? I won't be going in depth, but the steps, each step, how to just put the hypothesis, I will be just highlighting. So depending upon our research question, whether our research question is to test the association between the exposure and the outcome, we will be stating the null hypothesis first. We used to have it as there is no association. That will be our null hypothesis. Next, we will be setting our alpha. As I told, whether we fix it as 5%. If 5%, we have to consider 95% confidence interval, and the p-value has to be less than 0.05 for it to consider, for us to consider it is statistically significant. If we are fixing the alpha value as 1, okay, so then it has to be less than 0.01 for our estimate to be statistically significant, right? Next, what we do is we tend to identify our variables. Okay, so what is the dependent variable? What is the independent variable? How many groups are there? That we tend to identify them. Then what we do is we want to choose a test, statistical test, depending upon whether we are having continuous variable or whether we are having categorical variable, whether we are having only 2 groups or 3 groups. It is normally distributed or not normally distributed, or we are going to have a paired and unpaired observations in that sample. Based upon all these, taking into consideration all these things, we will choose one test. Okay, so based upon the test, we will be getting the test statistic, and from this we will be calculating something called as the p-value, and based upon the p-value we give our interpretation. So finally, p-value less than 0.05 is considered statistically significant, right? So this is how we test the hypothesis. Okay, so I hope till now you are all clear with those concepts. Okay, so first we started with what are the various study designs that we commonly use, and what is the measure of association for each of the study design, how to interpret these measures of association. Okay, so if odds ratio is 2, what will be the interpretation? If odds ratio is 3, what will be the interpretation? Prevalence ratio is 3, what is the interpretation? Those things we saw. Then we just got into this inferential statistics part. Okay, so where we have to study 2 things. One is calculate the p-value. Next, estimate the 95% confidence interval. So p-value, we can do it by testing the hypothesis. Okay, so what test to apply next? Okay, so depending upon our data, what test to apply, we will be seeing it. Okay, so for this to be determined, okay, so for us to choose an ideal statistical test, we have to take into consideration 4 things. Okay, so it depends upon 4 things. Each of the 4 things has to be considered to choose the test. Okay, so we need you just not straight away go with any of this statistical test by just looking into what is the type of the variable alone. Okay, so we have to look into all these 4 parameters to determine whether which to test to how our outcome variable is. Okay, so that is the dependent variable. Outcome variable is the dependent variable. Whether the outcome variable is continuous or categorical. Okay, so continuous is will be in numbers, right? 1, 2, 3, 4, like that. Categorical variable, say for example, this gender. Okay, so male, females, or a residence. Okay, so likewise, it could be in category. First assumption is that, or first point which we have to consider is what is the type of variable, that is the outcome variable, what is the type. Second thing is distribution. Okay, so here mainly we are worried about continuous variables only. Okay, so if it is a continuous variable only, we tend to look into the distribution, whether it is normally distributed or not normally distributed, where we tend to use these tests for normality, right? Okay, so either the numerical test, Shapiro-Wilk, KS test, or we can go with the histogram, QQ plot, and all. Okay, so second point is distribution of our outcome variable. Third point, how many groups are there in the dependent variable? Dependent variable is the exposure, right? How many groups are there? Whether we are having only 2 groups or we are having more than 2 groups. Okay, so say for example, okay, so if you want to test between the obesity and the cholesterol values. Okay, so if cholesterol values is the outcome variable. Okay, so if cholesterol, you might be knowing, we will be measuring it in continuous scale. Okay, right? So this obesity we can have, or the BMI, we can have it in 3 categories. So normal, overweight, obese, like this. If we have these kinds of 3 groups, or whether we are having 2 groups only. Okay, so sex and cholesterol value. If we go with sex, males, females, the outcome variable is cholesterol value. If it is such manner, that is 2 groups. Or if we have 3 groups, that also determines how to choose a test. The last thing which we want to consider is type of data. Okay, that is whether unpaired or paired. What is this unpaired or paired? Just simply remember, paired means same population we will be studying before and after kind of studies. Okay, so before giving the intervention, what is the measure? After giving the intervention, what is the measure? Or same population we will be doing repeated measures, that is known as paired. Okay, so because the variables will be related before intervention, after intervention, whereas in case of unpaired, we won't be having such a kind of thing. Okay, so before, after kind of thing and all will not be there. Say for example, if we want to study, okay, so by giving the antihypertensive drug, okay, into a population. Okay, so among the hypertensives, you are giving a newer antihypertensive drugs. You want to test how is their blood pressure, whether there is a increase in the blood pressure, whether there is a drop in this blood pressure. Okay, so in the same population, before giving this antihypertensive drug, what will be the blood pressure? We will be measuring it. Next, after giving the antihypertensive drug, what will be the blood pressure? We can measure it. It will be in continuous. Okay, right. Okay, so if we are doing in such manner, it is paired. Okay, so that is what the thing we have to consider. So we have to consider 4 parameters. One is how our outcome variable is, whether it is in continuous or categorical. Second is how is our distribution of this outcome variable. Mainly in continuous variable only, we tend to look for it. Either it is a normal distribution or a non-normal distribution. Next, we want to see how many groups are there in the independent variables. That is the exposure, okay, or the risk factor, right? How many groups are there? If it is 2, we will be using one kind of test. If it is more than 2, we will be going with another kind of test. Last thing which we want to consider is whether our data is paired or unpaired. Okay, so these are the things we want to look for before choosing our statistical test. Okay, so any doubts till now? Because understanding this is very, very important. And next I will be projecting one table. That is the most important part, or the most important thing from this entire SPSS workshop will be the next slide, which I will be projecting, where I will just combine everything and put it in a tabular form, so that if you just look into this table itself, you can easily pick it up what test to apply if our data or if the situation is like this based upon these 4 parameters. Okay. So any
Can you
doubts?
please explain paired and unpaired once again?
Yes, ma'am. Sure. So what is this paired and what is this unpaired? Okay. So paired means, as I told, same population. Okay. So as I given an example where we are giving the antihypertensive drugs. Okay. To the same population, before introducing the antihypertensive drug, what is the blood pressure? Okay. Say, for example, we have a sample of 500 hypertensives we are enrolling in our study. Okay. So at the baseline, we have measured what is their blood pressure. Okay. So then we start them on an antihypertensive drug. Okay. So after some time, or say, for example, after repeated 3 or 4 follow-ups, we are again measuring the blood pressure after giving the antihypertensive drugs. Okay. So what is the blood pressure? If such kind of thing, same population, before intervention, after intervention, or repeated measures we are making in the same population, it is known as paired. Okay. Say, for example, hemoglobin levels. Okay. So during the antenatal period. Okay. So in the postnatal period, likewise, repeatedly, if we want to measure also, it is known as paired measurements. Okay. So they are related groups. Okay. So the groups will be very much related. That is paired. If it is not there, it means unpaired. Okay. It is quite as simple as that. Okay. Same population, before, after, it is paired. Or we are doing repeated measures, it is paired. If both are not there, it is unpaired. Okay. So anything else? Anybody want any other clarification before moving further?
Sir,
Hello, sir.
Yes, sir. Yes.
Sir, sometimes our p-value is significant, maybe 0.05, but clinically it is the result is insignificant. So what will be our overall inference to these things?
So we as in clinical practice, we might have a different kind of a thing, but based upon what measures we have made in our sample, we just go by that only. Okay. So based upon this statistical values only, we give our inferences. That is the ultimate purpose of statistics. We are not going to see about the clinical significance. We are going to see only the statistical significance, and only our inference will be based upon the p-value only. Okay. So in such kind of scenario, we might not get the same result as it has been given in the literature. Our sample might just behave in a different manner. Okay. So, or there might be some variable or some confounders that might have given us such kind of a result, but we need not go with in depth into it. But based upon our statistical findings only, we can give the inference. We just don't blindly go with the clinical findings and all, or based upon the frequencies and all, we just don't go with it. Only with the statistical measure.
Thank you, sir.
Yes.
sir, in the number of groups, two
Yes, ma'am.
groups, male or female is there, no, sir? Can
Yes,
we
ma'am.
take in female less than 60, more than 60, and do it as 2 groups?
No. Here I mean only the number of independent variables. Okay. So where we could have as males and females only, or you could have certain other measures where we have 3 groups, that can be done. But just in turn dividing the males into 2 groups, that and all we can do it only if we go for this what to say, if we have more than 2 groups and all, we can go for other methods like this repeated measures, ANOVA, that kind of statistical test can be done. But not as such, we just divide them into 2. Once again, already the dichotomous variables, we don't divide further. For frequency tables, we can do it. Okay, but for testing the association and all, we are not insisting on that, or we not go by that.
Thank you, sir.
Okay, I hope there are no further queries. Next, we will see this important table. So it will be somewhat difficult for you to just coherent the table in first instance. Okay, so what I advise is that you can just take a printout of this table. Okay, and you can just stick it in your wherever you might be, in your room or in your workspace or wherever. So if you just keep on looking into that, you can easily coherent those findings. Okay. Okay. So someone who already has an experience, okay, so in the statistics, or someone who knows the subject of community medicine, they might find it somewhat easier to interpret. But we have participants from other specialties too, and also other non-medical backgrounds and all are joined for this workshop. For their purpose, what I advise is that you have this recording. Okay, so you have this table, you just keep on working out. Okay, so for each of the scenario or each of the studies which you do, you just look into all these things. Okay, so first understand this table. Okay, so at the left hand side of this corner of this table, I have given the dependent variable. Okay, so the dependent variable is the outcome variable, right? So as per whether the outcome variable is continuous or categorical. First, I have divided it into two. One is continuous or categorical. Continuous if it follows normal distribution or not. Continuous whether it follows non-normal distribution. That is why I have mentioned it as parametric test or test which we use when we study the normal distribution. Okay, when we have normal distribution. Non-parametric test we use when we have non-normal distribution. At the last, you could see nominal or dichotomous. So that is the categorical variable. Okay, so our our dependent, that is the outcome variable, can be either continuous or categorical. If it is continuous only, we bother whether it is of normal distribution or non-normal distribution. Okay, if it is categorical, we don't look for this normal distribution and all much. Okay, best we go with the frequencies and percentages only. Okay, so if we have the dependent variable as continuous, okay, so we tend to find the mean, right? If it is normally distributed. Whereas if it is not normally distributed, we calculate something called as mean ranks. We need not calculate these and all. Okay, so the software itself gives us. Okay, so it will convert our data points into ranks if our data is not normally distributed. We not manually do it, our software will give us. We want to just give the interpretation based upon that. Okay, so next come on to the right hand half of your table. Okay, so where I have divided into two. So groups in independent variable. If we have only two groups in independent variable, or if we have more than two groups in the independent variable. Okay, so next is this, whether it is paired or unpaired. Okay, so as I told in the previous slide, we want to look into four things. First point is, what is our dependent variable, whether it is continuous or categorical. Second point is, how is our dependent variable distributed, whether it is normally distributed, not normally distributed. Third point which we take into consideration is, how many groups are there in the independent variable, whether we have two groups or more than two groups. Next point we consider is whether we are using a paired observation or a impaired observation. Okay, so first box, let us see. Okay, if our data is continuous, the dependent variable is continuous and it is following normal distribution, we are having only two groups in our independent variable and it is unpaired. What is the statistical test that we tend to use here is, anyone, any guesses? We tend to use something called as the student t-test. So t-test is used if our dependent variable is continuous, okay, and it is of normal distribution. We have only two groups, okay. So quite commonly, and it is unpaired, quite commonly used test is this student t-test. Say for example, as I told in the previous example, males and females, what is the cholesterol values in males and what is the cholesterol value in females? Okay, so here the cholesterol value will be the dependent variable, or also known as the outcome variable, right? So the outcome variable is in continuous. Cholesterol values we have it in continuous, and we assume that it is normally distributed. And we have only two groups in the independent variable, right? Male, female, only two groups. And male, female, we are not going with any kind of a paired measure before, after, and all. We are not going to check. So it is unpaired. So if it is such a scenario, then we go with something called as the student t-test, right? So exact counterpart of student t-test if our data is not normally distributed. Okay, so all the other things are same. Okay, so dependent variable is continuous. Okay, we have only two groups in the independent variable. It is unpaired only, but our outcome variable is not normally distributed. What is the counterpart of student t-test? We have something called as the Mann-Whitney U test. Okay, so if you just click these tests, you will get the p-value, and just we can go with the inference and all. But choosing an ideal test is very, very important. Okay, so next scenario, we have a categorical variable. Okay, so it is not continuous. The dependent variable is categorical. Again, the independent variable is also categorical only, and we are having unpaired. Okay, so not before and after. So we have the dependent variable also, it is categorical. Independent variable is also categorical. It is unpaired observation. What is the test that we commonly use? What is the test which we commonly use, or which we are very much aware of? Majority of the people will be aware of this test. What is the test? So, right, exactly. So whenever we have categorical variables, okay, so your outcome is also categorical. Say, for example, male, female.
Fisher or
Okay.
Fisher exact? Fisher
Yes,
exact.
ma'am.
Fisher exact.
Yeah,
Fisher
Fisher. I will come to that, ma'am. Fisher exact. Yes, I will come to that. So what is this chi-square? Okay, so why we want to just use this chi-square in case of categorical variables? Say, for example, the same example itself we can consider. Okay, as I told, male, female, we are looking for the cholesterol values, right? If cholesterol, we have used it as a continuous variable, we can go with student t-test. Or else, based upon the cholesterol value, okay, so you have categorized them into two. Okay, high cholesterol, low cholesterol, or normal cholesterol. We have two categories. If such a scenario is there, we can always go with this chi-square test. Okay, so males, females, that is also continuous. Sorry, that is also categorical. And the outcome variable, the cholesterol value, okay, high cholesterol, low cholesterol, that is also categorical. If such a scenario is there, we go with this chi-square test. Okay, so we will formulate the 2/2 table, and we will be calculating the chi-square value, and p-value will be calculated. Right? We go with chi-square test. What is this Fisher's exact test? So in chi-square test, okay, so please don't go in depth into all the assumptions and all. It will be very confusing for you, and it is very difficult to remember. Okay, so each of this statistical test has few assumptions. Okay, so one important assumption of chi-square test is that all the 4 cells, okay, so as it is a 2/2 table, we will be having 4 cells, right? All the 4 cells, you should see that the value shouldn't be less than 5. In any of the cell, if you take, it shouldn't be less than 5. All the 4 cells, the value should be more than 5 only. That is one of the assumption of chi-square test. If it is less than 5, some cells where the value is less than 5 is there, such a scenario is there, then we go with Fisher's exact test, right? So if all the cells are more than 5, we go with chi-square, or kind of a corrected chi-square. Okay, so the yards correction and all we will be seeing, and we will be measuring the Fisher's exact test will be applied. Okay, so if any of the cell is less than 5. Okay. Have you all understood till now? Whether you are with me till now?
Sir.
Because
Yes,
each
sir.
thing we will be seeing one by one. So till
Yes,
now
sir.
we
Yes,
saw
sir.
about student t-test. Student t-test is a parametric test where the outcome variable is continuous, normally distributed, it is unpaired, and we have only 2 groups. It is student t-test. The exact counterpart of student t-test in the non-parametric is the Mann-Whitney U-test. Okay, so where only our data will be not normally distributed. Rest everything is same as student t-test. If both the exposure as well as the outcome both are in categorical, then we go with something called as the chi-square test. If any of the cells is less than 5, we go with Fisher's exact test, right? So next, if the same scenario, we have a paired observation, what will be the test which we can use? Okay, what will be the parametric test that we can use if it is a paired measure? What is the paired counterpart of student t-test?
Paired
Paired
t-test.
t-test.
Exactly,
T-test.
right. So it is paired t-test. Same population before, after. Before intervention, after intervention. Okay, so likewise, if you just want, if our research question is in such manner, our ideal test statistic will be the paired t-test. What is the exact counterpart of paired t-test in non-parametric? Some test
ANOVA.
which has rank. No. ANOVA is used only when we have more than 2 groups. Here we are dealing with only 2 groups. ANOVA is again, it is a
Wilcoxon sign rank test.
parametric test. ANOVA is a
Wilcoxon rank
parametric test, right?
Wilcoxon
Exactly.
rank sum test.
Wilcoxon's sign rank test. Exactly, ma'am. Correct. So it is Wilcoxon's sign rank test. Okay, so all these you need not memorize much. Okay, and this signed rank kind of thing, this transformation, everything we need not do. All these softwares will do. Only we want to apply this test. Okay, so one important thing which I want to just give you all is that majority of our statistical test has an assumption that our data is normally distributed. Okay, so let it be chi-square test, let it be Mann-Whitney, student t-test, or Wilcoxon. Mainly the underlying assumption is that our data is normally distributed, or majority of the test has been programmed in such manner only. That is why what we tend to advise is, it is ideal to use a parametric measure only. Okay, so unless there is no other way, only we tend to go with the non-parametric measures. Okay, so that is why if we have some kind of outliers in our study, which gives us a non-normal distribution, we tend to remove those outliers. And again, if you check the distribution, it might become non-normal. Okay, so the extreme values, if we have removed, if they are not going to have a major influence in our outcome, we can remove these extreme values. Then if you check the distribution, it might become a normal distribution. Then automatically we can go with the parametric test. Okay, so these parametric tests are considered much more reliable and much more beneficial when compared to this non-parametric test. So always try to going for these parametric tests if our data is normally distributed, or again if it is approximately normally distributed also we can go. Okay, so that is what this scientific, based upon the scientific literature or the statistical concept tell us. Even if our data is approximately normally distributed also, we can go with parametric test rather than these non-parametric tests. Okay, so same scenario, we are having a paired observation, but both are variables, that is the outcome variable as well as the exposure, that is the independent variable. Both are categorical. What test to use here? What is the chi-square counterpart, paired chi-square counterpart?
Spearman's rank, Pearson's correlation.
So no ma'am. Spearman's correlation and all, we deal with only if both the variables are continuous. Here both are categorical. What is the test we go for? Exactly right. It is McNemar's chi-square test. Okay, so the McNemar's test is what we go with. Why it is known as McNemar's chi-square test? Because it is based upon the assumptions of chi-square. Okay, all the assumptions of chi-square is met in McNemar also, and for interpretation also we tend to use this chi-square table only. Okay, so actually what we have to do, we have to use these tests and we have to calculate the values. Okay, manually we will be calculating the chi-square, right? O minus E, the observed value, expected value. If we do these calculations and all, we will be getting one value. We will be checking the chi-square table and we will be saying whether to accept or whether to reject it. Okay, so those things and all manually if you want to do, we have to do it. So McNemar's test also uses this chi-square table. That is why it is known as McNemer. Okay, so same example we can take it. Okay, say for example, if our outcome measure in parity test, what will be our outcome measure? As I told, you are giving one hypertensive drug. Okay, and you are looking for change in the BP. Same population, before giving the hypertensive drug, what is the BP you have measured? Then you give the intervention. Okay, then you measure the blood pressure. Okay, so next you can have comparison with another intervention or with placebo. Okay, so one group you are giving drug, one other group you might give some kind of a exercise or a dietary modification. Okay, so if you are doing it the before and after the intervention, what is the change in the blood pressure? If the blood pressure is continuous, we go with parity test. Whereas if we can just change this blood pressure, we can change it into categorical also, right? Normal blood pressure, high blood pressure, normal and high blood pressure. If we have these two categories, in such scenarios, we can use this McNemer's chi-square test. Okay, so both the variables, that is the exposure as well as the outcome, both should be categorical. And if we have a paired measure before intervention, after intervention, just for your easy understanding, I'm just keep on sticking with the same example, before, after intervention. Okay, so there are various other scenarios too, but for easy understanding or at the first time, you just remember these things alone. Okay, so then we can go for this McNemer's chi-square test, right? So any doubts till now, whether you are able to follow? So please stop me at any point if you are not clear with any
Yes,
of these
sir. Yes, sir.
concepts.
Yes, sir. We are
Right.
able to follow.
Yes,
Yes, sir.
thank you.
Thank you.
One doubt, sir.
Yes, ma'am.
If data collected from non-probability sampling, we use the statistical test or not, sir?
Yeah. You can go for this statistical tests and all, ma'am. But our reliability will be less. Okay, so as we have used the non-probability sampling method, our reliability only will be less, because there might be some kind of many confounders might be there, the sampling variations and all might be there, the errors, sample errors and all might be there. But we can use this statistical test. We can go with it. Sampling method doesn't have an influence on whether we to use or not to use any of the statistical tests. We only go by these assumptions, and it depends upon only our research question, study design, what is our independent variable, what is our dependent variable, and all these measures only we take into consideration.
Thank you, sir.
Yes. Okay, so next, moving further, we have still now we saw only about two groups. We had two groups only. Now, if we have more than two groups, say for example, we are having three groups in our data set. Okay, the three groups are independent. That is the exposure only. As I told earlier, okay, so normal, obese, overweight, like that, we are having three categories or three things. We have three age categories itself. Okay, say for example, less than 25, 25 to 50, more than 50. Likewise, we have three age categories. Okay, so then we want to compare our outcome variable. Say for example, our outcome variable might be cholesterol levels again. Okay, so same example I am sticking with. Okay, yeah, kindly if the participants can mute themselves. Right, okay, we will move further, right? So where are you at? Right, okay, so same way as I told, if the outcome variable is cholesterol, okay, and we have three age categories, we have categorized them. Okay, so remember, we are not using the age as a continuous variable, we have categorized them. Okay, so whether there is a significance or there is an association between any of this age category with this outcome, that is the cholesterol value. If we want to check such a thing, okay, where our data is normally distributed, we have more than two groups, okay, and we are having only the unpaired, okay, so not before and after. What is the test which we ideally go for?
One way ANOVA.
ANOVA. Yes,
One way
exactly.
ANOVA.
Exactly.
One way ANOVA.
Yes, ma'am. Yes, ma'am. It is one way ANOVA, right? What is the non-parametric counterpart of one-way ANOVA? Here only the data is not normal distributor. Other all are same.
Wallace.
Yeah,
Crystal
exactly.
Wallace.
Excellent, excellent. It is Kruskal-Wallis test. Okay, so Kruskal-Wallis test is the non-parametric counterpart of one-way ANOVA. Okay, so what is the test we use if a data is categorical? Okay, so both the dependent as well as the independent variable both are categorical, and we are having the independent variable is in 3 groups. What test we can go with?
Chi-square again?
Yeah, exactly. Chi-square again we can go with. Okay, so because chi-square can be used even if our data has more than 2 groups. Okay, so if the independent variable is more than 2 groups, same chi-square and Fisher exact test can be used. Okay, so I hope next same scenario. Okay, so but we are having paired observations. Okay, so before or after or repeated measures. That is the scenario normally distributed. Okay, but more than 2 categories, and it is a continuous variable. What is the measure we can use, or what is the test we can use?
Repeated measures ANOVA.
Yes, it will be repeated measures ANOVA. That is what we go with. What is the non-parametric counterpart of this repeated measures ANOVA? Anyone?
Friedman test.
Exactly. It is Friedman test. Okay. So if it is categorical, what is the test that we go for? But it is not quite common. Okay, so rarely only we could see such a scenario. Okay, so where we can go for something called as the Cochrane Q test. Okay, so don't worry about this Cochrane Q test, Friedman test, and all. Quite commonly we won't be using it. So commonly used tests will be this student t-test, paired t-test, ANOVA, chi-square. These are the 4 commonly used tests, and rarely we might go for non-parametric tests if none can be done. Okay, so if there is no other way, you have to just present your data only in non-parametric tests, then we can go for those tests. Okay, so I'm not
So what?
Yes,
So
yes.
what is ANCOVA? ANCOVA.
Ma'am?
ANCOVA test.
ANCOVA.
Yes, sir. Sir, ANCOVA is analysis of covariance. Can you explain about it?
Hello.
Yes. Can you hear me?
Yes, Vijay.
Okay, okay. Sorry that I had some internet connectivity issues. Okay, so where were we? Yes, ma'am. What was the doubt that was asked? Ma'am, I was not able to hear you.
So there is a test called ANCOVA, analysis of covariance.
Yeah, analysis of covariance. Okay, so it is different. It is like ANOVA only, ma'am. But where in case of ANOVA, we have an assumption that there is no covariance. Okay, so if there is no covariance only, we tend to go for this ANOVA. If there is covariance, that is this, there is some kind of a dependence in this independent variables. Okay, so then we can go for this ANCOVA and all. Okay, so it is not that much needed in our day-to-day practice, but we commonly go with only ANOVA in our day-to-day practice.
Okay.
Okay, so can you all just follow? Any doubts with any of this covered till now? Okay, so this one table, if you just remember, it is more than enough for you. Okay, so depending upon whether our outcome variable is continuous or if it is following the normal distribution or not, whether our independent variable is paired, how many groups we have, whether 2 groups, more than 2 groups, paired or unpaired. Okay, so all these things we need to take into consideration to choose an ideal statistical test. Okay, so I hope we are very much late by time, and I will just quickly finish off with this concepts. Okay, so next we will be going to if both the variables. Okay, so if the
Kindly show the previous slide again, just one.
Yes.
Just previous one. That table one.
Sure. So you can just sit back and you can just look into the videos, look into this table, and depending upon what is our research question, what is the study design which we are using, okay, how many groups are there in a study, all these things you can take into consideration for calculating the statistical significance. Okay.
So I have a query. I have a
Yes.
situation like we are giving a drug
Yes, ma'am.
and the change in the VAS score, pain score.
Yes, ma'am.
So before we give the drug
Visual
and
analog
after we
score, right? So you are going
yes,
to
sir.
test the visual analog score, right?
So
Yes, ma'am.
here it is before the drug, after the drug,
Yeah.
and the
The
VAS score
score
has
you are having, whether you are having it as continuous or you are just going to categorize it.
yes, sir. I think we should categorize it. Make
Okay,
sense
so
in categorization.
yes. So
Yes,
here
sir.
your outcome variable will be the pain score, right? Visual analog pain score,
Yes, sir.
which we will be categorizing it, right?
Yes, sir.
So your
But it will be more than three categories.
yes, ma'am. It will be more than 3 categories, right? Okay, so
Yes.
if such a scenario is there before and after, then you can go for this Cochrane Q test. I myself haven't used this test, but if such a scenario is there, we can go for this Cochrane Q test.
I've never
It will
seen
be
this test getting used.
yes, ma'am.
Other than this test, what are the options we have?
If you just directly have this pain score in continuous itself, you can go for this repeated measures ANOVA.
And if we don't use it as continuous and we have more than 2 groups, then can we use McNamara in this?
No, McNamara can be used only if you have 2 groups. Okay, so depending upon what is your independent variable, ma'am?
Independent variable is the drug.
Drug. Okay, so then you can go with McNamara, right? You can go with McNamara. If you have only 2 groups, you can go with McNamara. The independent variable is only 2 groups. McNamara is enough for you.
And so 2 groups and greater than 2 groups, this is based on independent variable.
Yes,
So our
independent
independent variable is 2
here
groups
is
only.
here it is your drug.
Drug,
Okay.
yes, sir.
Okay, one group you might receive the drug, another group it might not receive the drug or might receive an alternate drug. Okay, so here we have only 2 groups. So in such a situation, you can go with this McNamara's test. If your outcome variable also you have in 2 categories only.
Sir, it is not, it is paired before the drug, after the drug.
Yeah. Two categories,
It is
before, after,
paired
you can go
after.
with McNeil.
And the outcome is multiple categories, but the independent variable is two categories. So it will be McNamara.
Yeah, sure,
Yes?
but
Okay.
it should be dichotomous only. The outcome variable should be dichotomous.
Outcome is not dichotomous, sir. Outcome is more than 3.
Okay.
Outcome is,
What are the outcomes you are going to test? The visual analog score only, ma'am, I'm asking.
yes, sir, but there are 3 categories in the outcome.
Okay, so how you just divide this visual analog score into 3 categories, no? How
Well,
you are
like
just
1, 2, 3, 4 to 5, greater than 5.
okay,
Or
okay.
we can also see reduction in score.
Okay, so before how it is and how after how it is. Okay, so if you are going to see this reduction in the scores and all, it will be ideal to have it in this continuous only, no, ma'am.
Continuous, yes, sir.
Yes, it should be in continuous. The score should be in continuous. You can't categorize them. Okay, so it is better you have it in continuous itself.
So it will be Wilcoxon then.
Yes, ma'am.
Then it will be Wilcoxon if we are using it as continuous.
Yeah, it will
If
be
we are just
Wilcoxon if it is non-normal distribution. If it is normal distribution, we can just
okay,
go
yes,
with
sir.
parity test, right?
And one more question, sir. So I have seen where people are using Wilcoxon sign test and Wilcoxon sign rank test. Is it different or is it the same?
Wilcoxon's?
Does this word rank make a
Yes, ma'am.
difference? There is Wilcoxon sign test and one is
Okay.
Wilcoxon sign rank test. I've read it two differently. Is it
Yes,
different
ma'am.
or the same?
Yeah, it is different only, ma'am. Sign test is totally different. Okay, so we can't cover it right now. Okay, but this Wilcoxon sign rank test, what the assumption is that all our data points will be converted into ranks. Okay, so as we do in case of this parametric, where the normal distribution, we convert it into mean. Okay, same way our data points will be converted into the form of rank. Okay, so linearly it will be arranged. Our data points will be arranged into ranks, and that is why that is what this test result will give you. Okay, based upon the mean ranks. Okay, so that is what this Wilcoxon sign rank test is.
Okay, sir. And one more thing, sir. While you're discussing the statistical test,
Yes,
please
ma'am.
also discuss about the test for reliability.
Yes, my test for
Reliability, measuring reliability. There
yeah,
are
ma'am.
multiple Bland, Altman, etc. Where to use which one?
Yes, ma'am.
That is
That
also important.
I think that won't be covered for today, ma'am, because we are already past our time. We have still more this correlation regression and the hands-ons and all will be there. As I told it before lunch itself, we will be planning for a doubt clearance session in Monday. Okay. You are free if things you just put it in the WhatsApp group. If possible, we will take it. Okay, so we will have the doubt clearance session for 1 hour to 2 hours. During that time, any doubts or anything you want us to reiterate or anything extra it has to be covered, we can just see to it. But exactly because
Sir,
it is
just 1 second. Sir,
yes.
in the beginning, I think you discussed that to test the normality of the test, we have that Kruskal-Wallis test. We have that for testing the normal Shapiro-Wilk and that Kolmogorov-Smirnov test. For testing normality, that is Kolmogorov-Smirnov and Shapiro-Wilk test. And another test you told something new name, I think. Another
That is
test.
Anderson-Darling test.
Anderson-Darling. Okay.
Yes. So if you have anything, any more thing that has to be covered, we can cover it in the Monday doubt clearance session. But as it is just a primer in SPSS data analytics, we are not going to cover any of the higher level of statistical inferences that we commonly use, the ROC curve, the survival analysis, the hazard ratio, the bootstrapping. All these things will not be covered in this a primer workshop. We are planning for an advanced SPSS data analytics workshop where we will take up all these things. But a few things which could be easily covered, if you just want us to be covered, can be covered on Monday. But today it won't be possible as we are moving very short of time. Okay, to just to go further, so if both the variables, both the exposure as well as the outcome variable, if they are continuous, okay, and it follows normal distribution, we go with Pearson's correlation. Okay, if they are not normally distributed, we go with something called as the Spearman's correlation. Okay, so these two things also will be covered in next session by Dr. Kavin Kumar. He will be dealing with correlation and regression, where he will just go in depth and give the inferences about these things. Okay, so next quickly we will see about certain exercises. Here I want the participants to give your inputs. Okay, so we are going to do a study, okay, to identify the risk factors of ectopic pregnancy among pregnant women. Okay, so we are going to test the hypothesis between prior history of cesarean section and ectopic pregnancy. Okay, so if such a scenario is there, what is the test that you can use? Okay, so you're going to test the association between cesarean section, history of cesarean section and ectopic pregnancy. So ectopic pregnancy will be as, yes, exactly. Why, sir? Can you give your inference? Interpretation?
As it is independent, it is unpaired variable. Both of the variables are unpaired variables.
Yes. Yes. So the variables, first thing is,
And
it is
categorical and unpaired.
yes, sir. Exactly, sir. It is categorical first. So history of cesarean section, it is categorical. Okay, so either it could be yes or no. Same way for ectopic pregnancy, that is also categorical. It could be either yes or no format only. And we couldn't find any kind of a paired observation in this scenario. So the ideal test in this scenario will be the chi-square test. Okay, so next moving on to another one exercise. Okay, we are doing a study to estimate the body mass index, that is BMI, among individuals with history of cardiovascular disease and without history of cardiovascular disease. Here the BMI follows normal distribution. Okay, what will be the ideal test in this scenario? Anyone? Can you just please either unmute or you can just put it in the chat box. What is the ideal test you can use?
Student t-test.
Yes, student
T-test.
t-test. Okay, so why do you say it is student t-test, ma'am?
The outcome variable BMI are continuous variable.
Yes. Next.
Two groups, history of cardiovascular disease without history of cardiovascular, two group of people.
Yes, that is the independent variable. Exactly. And the BMI is normally distributed. Okay. So in this scenario, what is the test which we can use? Here is this student t-test or unpaired t-test. Okay. So next scenario, we want to study, we are going to do a study to examine whether Apgar scores of babies born through normal vaginal delivery and cesarean section. We are going to compare the Apgar scores of babies born through normal vaginal delivery and through cesarean section. Here Apgar score is not normally distributed. What test?
Man-Whitney.
Why it is Man-Whitney, ma'am?
Because there are two categories, C-section.
Yes. So C-section. So we have vaginal as well as cesarean section. That is the independent variable. The dependent variable here is the Apgar score. As the Apgar score is not normally distributed, we can go with Man-Whitney U-test. Okay, so next scenario. Okay, so we are going to compare the mean cholesterol levels among males, females, and transgenders. Okay, so look into the question. Comparison of mean cholesterol levels among males, females, and transgenders. The mean cholesterol follows normal distribution. Yes, exactly. It is a one-way ANOVA. As we are having more than two categories, males, females, and transgender. The independent variable is more than two, and the outcome variable is cholesterol levels. So this follows normal distribution. So the ideal measure or ideal test to use here is one-way ANOVA. Next scenario. Okay. So you want to study the impact of dietary modification program on the daily average calorie intake among diabetics. The average calorie intake follows normal distribution.
Pair t-test.
What test? Yes?
Pair t-test.
Exactly. Okay. So before intervention, after intervention. So we are going to give a paired observation, and it is normally distributed, and the outcome variable is continuous. That is, the calorie intake is continuous. Okay. So this is paired t-test. We have to go with paired t-test. Okay. So excellent. I hope all of you have understood. And this is again, this measures of association. How to calculate these measures of association? Directly, we can go with any of these regression techniques to calculate the measures of association. As I have just mentioned, okay, so if we are having a quantitative variable, we can go with either linear regression or logistic regression. Logistic regression is done only in case of case control study. Whereas this linear regression, we can be using it either in cross-sectional, cohort, or experimental studies. Whenever we have a qualitative or categorical variable only, we can go with other forms of regression like the binomial as well as the Cox regression. Okay, so this Cox regression and all will not be covered in this workshop. Other types of regressions will be shown in this workshop in the further sessions. Okay, so next, quickly moving on to the confidence interval. Okay, so this also I hope I have just cleared it in the first part of my session itself. Okay, so confidence interval, this 95% confidence interval, it means what? Okay, for this measure of association, that is for odds ratio, the relative risk, as well as the prevalence ratio, we have some interval. Okay, so if odds ratio is 1.5, the confidence interval will be 1.1 to somewhere around 3, like this. If it is in such scenario, if it is in such manner, what does this 95% confidence interval mean? So 95% confidence interval means that 95% times, okay, so our population measure will lie in these two
95%
range only. Okay, yes, ma'am. So it will be within these two limits only. Okay, so that is what this 95% confidence interval means. Okay, so that is what this confidence interval is. Okay, so with an example, if you want to see, we are doing a study to assess the prevalence, or to estimate the prevalence among adolescent girls. Okay, anemia prevalence among adolescent girls in one area, site A, site X, let it be. Okay, so we have recruited 244 adolescent girls from this site A. Site A might have so many adolescent girls, but we have calculated the sample size as 244 based upon some sample measures. Okay, and these 244 adolescent girls only we are picking from the total population. Okay, so in our study, the anemia prevalence might be 70%. But in the population, it might vary. Okay, so this confidence interval gives us that variability of this measure only. Okay, so it might vary from 65 to 75. So true prevalence of anemia among adolescent girls in that population might lie within 65 to 75 in 95% of the times. Okay, so that is what the inference that we give based upon this confidence interval. Okay, so confidence interval gives us much more information when compared to p-value. Okay, so it gives us what is the strength of association. Okay, so whether it is positive association, negative association, and also direction of this effect. Okay, so if it is more than 1, if the measure of association, say for example, the relative risk or odds ratio more than 1, it gives us positive association. If it is less than 1, it gives us a negative association. Okay, and also the precision of the point estimate. Okay, how it varies. Okay, as we have the upper limit and lower limit, this variability also is being given by this confidence interval. So confidence interval gives us much more information rather than just the p-value. So as I insisted in the first part of the presentation itself, whenever inferential statistics, the word comes to your mind, you have to think of only 2 things. One is p-value, second one is confidence interval. Okay, so with this, I think I can just wind up this session. Okay, so to summarize, I will just quickly summarize what all we have seen so far. So first, I just introduced you to the various study designs, and we saw various measures of association for each of the study design. And one take-home message, as I told, never use odds ratio as a measure of association in case of cross-sectional studies. Only prevalence ratio has to be used, because if we use odds ratio And if the prevalence that we have calculated in that study is high, definitely we will be overestimating the risk. Okay, and if inferential statistics, we have to look for two things. One is p-value and confidence interval. Okay, so with this, I think so I can wind up this session. So any more doubts?
Sir, as you said that the magnitude of the effect can be given by regression model also, no?
Yes. It can be given by regression model. From this regression model only, we will be calculating this measure of association. And we will be calculating the confidence interval also will be given by this regression model only. As I have just projected in this slide. Okay. So the measure of association, we can pick it up by doing any kind of a regression technique only. Okay. So let it be a linear, logistic, binomial, whatever it might be, depending upon our study list. Anything else?
Sir, in many study, in the prevalence study, in odds ratio, adjusted odds ratio, and the tabular column sir. If prevalence cross sectional study எல்லாம் பண்ணோம் நம்ம யூஸ் பண்ணக்கூடாது, odds ratio யூஸ் பண்ணக்கூடாதுன்னு சொல்றீங்கல்ல சார். அது நிறைய மாடல் ஸ்டடியில odds ratio, adjusted odds ratio அப்படிலாம் வரும்.
Yes, ma'am. Adudha, ma'am. That is a wrong thing, ma'am. That is a wrong kind of interpretation, because what we will do is that if we just use odds ratio in place of prevalence ratio, definitely we will be overestimating the risk. Okay, so it is kind of a statistical assumption only. Okay, so we have specific statistics for each of the study designs. Okay, so இப்போ வந்து நம்ம odds ratio பதிலா ultimate the result எல்லாமே வந்து சிமிலரா தான் மேம் வரும். ஓகே, பட் the term வந்து பாத்தீங்கன்னா வந்து we have to use it as prevalence ratio and we shouldn't use the term as odds ratio. Okay, so prevalence ratio and adjusted prevalence ratio, that is what we have to use in case of prevalence studies. Okay, so நிறைய articles இல்ல நிறைய journals they are doing that, but if you just send your manuscript to a very good reputed journal இல்ல ஒரு international journalக்குலாம் வந்து நம்ம வந்து if you are sending the articles, they will definitely point out this mistake and ask you to just correct it. Okay, change the measure of association to prevalence ratio as it is a cross section study. Okay.
ஓகே சார். அதே மாதிரி இப்போ ப்ரிசிஷன் பாயிண்ட் எஸ்டிமேட்டை நம்ம இப்போ இன்க்ரீஸ் பண்ணோம் 7%, 10% இன்க்ரீஸ் பண்ணோம்னா நம்மளோட 95% கான்ஃபிடன்ஸ் லெவல் அது வேரி ஆகுமா சார்?
மேம் நம்ம அது ஆல்பா செட் பண்றது தானே மேம், அது வேரி ஆகும் மேம் கண்டிப்பா. இப்போ 5% ஆல்பா வந்து 5% இருக்கிற வரைக்கும் தான் ஆல்பா எரர், தட் இஸ் த ப்ரிசிஷன் ஆர் த எரர் விச் வி ஜஸ்ட் அசியூம் 5% நம்ம வச்சோம்னா it will be on 95% confidence interval. அது இன்க்ரீஸ் ஆகும்போது இந்த கான்ஃபிடன்ஸ் இன்டர்வல் ஆல்சோ மைட் பி சேஞ்சிங்.
ஓகே சார், தேங்க்யூ சார்.
Okay, as it is very much past our scheduled time, we will go on with this quickly. Yes, ma'am. Yes, ma'am. Actually, you are not audible, ma'am.
The outcome variable is categorical.
Yes, ma'am.
Then we can use the other forms of regression also, like Cox regression.
Yeah. That also can be used.
So what are the other forms? One is logistic, one is linear, and other is Cox regression and
binomial regression.
Binomial logistic regression.
Yeah, binomial regression. Okay, so next we will just move on to the next session. So I just invite the next speaker, that will be Dr. Kavin Kumar. So, sir, are you available, sir?
Hello.
Yeah. So just a small intro about the resource person. So Dr. Kavin Kumar has done his MBBS from the government Mohan Kumar Mangalam Medical College, and he has done his post-graduation, that is MD in community medicine from the Government Medical College, Nagpur, and is currently working as a assistant professor in Swami Vivekananda Medical College, Tiruchengodu. And his areas of interest include the medical research, medical education, and also disease-specific researches also he has undertaken main. Okay, so with this short intro, I would like to invite Dr. Kavin Kumar to kindly take over and proceed further.
Hello, Vijay. Thank you.
Yeah, Yeah.
Good evening, dear participants. So till now you have seen many statistical programs and analysis techniques, statistical tests. So now we are going to briefly touch upon mainly the basics about correlation and regression. So I think my screen is visible now.
Yeah, it's visible.
Yes. So good evening, everyone. So this session will be just a primer. It won't be an in-depth evaluation of all those techniques in correlation and regression. I will just briefly touch upon and give you an idea why we use when we use correlation and when we use regression and what we get out of this both the techniques. So the idea will be approach to quantitative variables in research, understand the concept of correlation and interpret the correlation coefficient, and understand the purpose and the basics of regression. So now let us see this case, which will give you an overview. Let us assume that you are in an accident and emergency department. So in that department, there are 20 patients you have seen in the past 1 week. So now we want to know whether there is any relationship between the and you collect various information from these patients. Specifically, you have taken age and the urea level and the blood. So when you have collected this information, now we wanted to know whether there is any relationship between these two variables, that is age and the urea level of the patients. So anybody can give some insights about this ideas? How do you approach this scenario? Our idea is we have two variables, area, age, and the urea level. Now, how would you approach these variables? Any general insights? Do you have any general ideas?
Yeah, we can have the 20 patients. Like if we have a significant number of patients, we can have different age groups and different urea levels of each specific like person. Then we can have two statistical tests to find the relationship, because both and that first is a correlation we can do.
Okay, good. Okay. So
and yeah, the correlation will be suffice it, I guess.
Thank you. So this is the data. This is the dummy data. So don't need to worry about this data. So age and the urea level. What is the type of variable? Age and the urea level.
Continuous variable.
Yes, it is a numerical variable or a quantitative variable, and it is continuous in nature. So which variable is dependent and independent? Any guess?
Urea level is a dependent variable and age is independent variable.
Age is independent variable. Urea level is dependent.
Urea is the dependent variable, which is dependent upon the age, which is an independent variable, because depending upon the age, the urea level may either increase or decrease. So we will see that in next slide. So when you are given this two quantitative variables, you take any two variables, whether it is a BMI or it is an age or urea level or blood sugar level, take any quantitative variables. What would you do at the first instance? That is the idea of this class. So remember this figures long ago, 10 years, 20 years back from now. We could have used in our standard 10th and 12th standard days. They used to give some 10 numbers in two columns. We used to do the plotting of these things and we used to derive some graph out of it. Yes. So that is what the idea we are going to exploit right now. So now in the first instance, this first step, we are going to plot these variables that is given in the data. We are in this graph. We already mentioned age being an independent variable, we will plot it in the x-axis, and urea being the dependent variable, we will plot it in the y-axis. So when you do this, you will get something, some graph like this. age being in the x-axis and urea being in the y-axis, and we will plot this data in this graph. So now, what would you infer from this data? That is the question right now. For this, there is two-step criteria. First, at the first instance, just look for the trend line. What is the trend that is being shown in this entire graph, which will give you the idea whether this age and urea are related or not related. Second thing, look for the closeness of these values towards the trend line. If there is a trend line, if we can imagine an imaginary trend line here, then whether these values are close enough to this trend line, this will show you how strong is this relationship in the first instance. So as we can see this is an imaginary line that is being drawn in this graph. You can see it goes from towards the right, from the bottom left to top right. So you can see this values that are close enough to this trend line. There are very less number of values that are close to the trend line. So the inference is this is a kind of a positive trend line, a linear relationship going towards the right side, and all the values are not close to the trend line. So it may be a weak relationship. We cannot confidently say whether it is a weak or a moderate relationship. We will come to it later. But assuming at this first instance, we could say only it is a positive trend line that is being going from the left to right, and it may be a weak relationship. Okay. So now, in research, in medical research or in any discipline, we always try to measure any phenomenon or any occurrence that is happening in the research. So now we had seen there is some relationship. Until at this point of time, we could see there is a relationship between this age and the urea, and now we are going to measure this relationship. So what is the idea, or do you have any insights about how to measure this relationship between these two variables, two quantitative variables? Any guess? Anyone can unmute and
Pearson and Spearman correlation.
Okay, good. So
Pearson's correlation coefficient.
Yes, Pearson's correlation coefficient. So you can use this Pearson's correlation coefficient technique to measure the strength of this relationship. We could see there is some kind of relationship, and there is maybe a weak relationship, but we are not yet confirmed it. So we are using this Pearson correlation coefficient to confirm this relationship. So this is a vague formula. Please don't worry about this formula. There is some software which will give us this Pearson's correlation coefficient. So just for the information, I am giving this formula. So now, if you could input this data during the hands-on training, the correlation coefficient will be given by the softwares like Spss. So the coefficient for our data, for our sample data that we have given in the case Vignet is this correlation coefficient R is equal to plus 0.61. This is the idea. So now we are going to interpret this correlation coefficient, that is R is equal to plus 0.61. So in this R, there is a sign that is plus or minus, or followed by a number. It is either ranging from 1 to plus 1 to minus 1. So there will be a sign and a number. The sign will give you the direction of the relationship, whether there is a positive relationship going from the towards the right, line going towards the right to the upper side, or there can be a negative relationship, the line going from the top left to bottom right. So the number will give you the strength of the relationship. It means how strong is the relationship. Even in our apart from the medical terms, we could see some relationship, right? Being brothers and sisters, close friends. The relationship may be just weak to moderate. Close friends, the relationship will be very strong or very perfect. So that gives you the closeness of this relationship. There is it can be either -1 to +1. If there is no relationship, then the value will be coming around the 0. It can be either a no linear relationship or a non-linear kind of relationship. So this is an example of positive correlation, that is line going towards the right. That is example of negative correlation, line going towards the left, towards right, but going to the bottom. Whereas one shows the strength of the relationship. Now you can see in this graph, all the values are as close to this line. Also, it is lying on the line itself. It shows that it is a perfect, strong relationship. Similarly, in the negative, the line is going towards the bottom right, as well as all the values are lying over the line. So it is a strong, perfect, negative correlation relationship. So now you can see this graph. It is more or less same. It is line is going towards the right, so it can be a positive relationship. But the thing is, the points, the correlation points are lying away from the line, so it is a weak to moderate kind of correlation. Similarly, the right side you can see the line going towards the downside, so you can also it is weak in nature. So negative or minus 0.3 is the correlation coefficient. So my idea is to just give you the this graphical scenario, so you will get this out of this softwares. But once you get out of this softwares, you should know how to interpret this figures or the scatter plot. So a brief quiz. So can anyone unmute and say the relationship in the left and right figure?